Hi, today I want to show you how to make your own printed circuit boards. For example, if you want to build my doorbell I showed in another video on this channel, and if you have done some soldering work yourself, you may know this can get quite ugly. So this video is sponsored by JLC PCB because they make very delicious circuits. Well, I would not recommend companies or work with companies where I'm not convinced that they do a very good job. And in this case, JLC PCB is my best sponsor, but I could work in my regular job for around 2 hours and have more than I get from my sponsors because my channel is quite small. But nevertheless, this is an opportunity for you to get a free video, for me to get some money, and for the sponsor to get some attention. So I hope you enjoy that. So we won't waste time, we get into details now. I'm using EasyEDA from easyeda.com as the creation tool for PCBs. You can of course use KiCad. I didn't try that for myself, but this is the open source alternative. I will give it a look in soon, I think. But EasyEDA is also fine. It's not open source, but it's free. You can get a professional version, but it's already packed with features. So it's perfectly integrated, for example, with JLC PCB. And yeah, for me, it's good enough to create my stuff. And when it doesn't get too complicated, it's suited for your needs, I would say. So you have two options. You can use the online version. I guess it's the you have to log in for it, or you download the client, and that's what I have done. And let me show you what you can do with it. So I create a new project. Sorry for the German menu. I try to change the language to English. No. Oh no. English. Okay. English I understand a little bit. So you can create here the circuit sheet. So when you have to plan your electrical routes and don't want to get into PCB design directly, you can make your plan right here. I didn't do that because I worked directly on the breadboard and my PCBs are quite simple. So I directly started to the PCB design, and this was not a pain. It's quite simple and straightforward. So there's just one thing which you have to set first. This is the units. You have millimeters and mil. I don't know actually what mil means, but seems to be another unit. And here you can see your basic sized PCB. This is 10 centimeters squared. And when you look at JLC PCB, then you can look up their capabilities. And as you can see, the default dimensions where you can order for $2 are around 10 centimeters in square. And this is mostly the biggest PCB size you may use. Most of the time it's smaller. Let me show how you can make it smaller. You see here this grid. This is perfectly aligned with the default breadboard and modules, like the ESP cam module, for example, or just Arduino pins. And I tried this with open the library, and then you just search for a simple pin header, and here you got 2 pin headers. Place one, and then you can see, okay, they fit perfectly on here, but you can change the snap size a bit. I would say half snap size. The grid size is 100 mil or 100,000. I don't know. And yeah, here can you see it's now snapping in half steps, and then you can of course use the Alt key, and I do it even smaller here. If you press Alt, you can do quarter steps. But you can see these are the right sizes for a typical pin header, and then we can work with this. So if you now press the 3D view, you see your 10 by 10 centimeter PCB without nothing on it, and you can of course build your whole thing on this and cut it yourself, but I wouldn't recommend to cut it yourself. It smells like death. It's very chemical based material. I guess it's fiberglass and more or less chemicals, and it smells very unhealthy. So you can better create the sizes like you need them. And here, for example, let's see how these sizes are. I will change to millimeters for now. So have a look. We have 76 and so about 7 times 3 centimeters. And let's get back to mil. And this, for example, is a board where we can work with. And let's see, it's already updated here. And what can we do with it? We have here the possibility to just add simple holes for pin headers, for example. And then you can adjust the sizes like you need them. Just have a look at the capabilities. What can the machines do at JLC PCB, like drill hole size, and have a bit of look at this. This is the millimeters units they're using here, but have a look at these so you won't get into trouble when the PCBs are in production. And yeah, let me give you a tip for creating your PCB. When you want to make cable routes or tracks, you can do it, of course, all manually. But if you, for example, have multiple contacts, like I will, for example, go for the net ground, and I just copy them, for example, like so. And then you have another grid, another net, for example, VCC. I also copy them like hell. No one would do this. So then you can make visible the red lines, and yeah, there you can see some visualization which parts are connected together or will be connected together. And when you do this, you can do this manually, and you can always see where you have to go. But you can also do the auto routing. It's cloud-based, or you can install a local program for routing. And here you can also do design rules. For example, if you want to make bigger track width on ground, you can set this here. The default I set for 20, for example. The bigger, the better for if you want to get much power through these tracks. But I guess for our task, it's already fine in this size. Yeah, and here you can see it already routes the tracks. And you may ask what are the colors meaning here. You have two sides of the PCB, the top layer and the bottom layer. And of course, you can't cross through these different lines because that would short between VCC and ground, and that was created automatically, so it's fine for me. And when you consider how the production on the factory is done, it's the copper layer is already on the board, on the board. The copper layer is already on the board, and it will dissolve in some chemical stuff, and the more copper have to be removed, the more chemicals they need. So if you want to make their job easier, you can do a copper layer like this copper area, or press just E. And this is also good for shielding, and you may save some cables there too. And here you can see that every ground layer now is just connected to the copper layer, which is fine. And where you can here you can see that there are some strange holes here, and this is actually very clever, because when you're soldering on this plate, very much of the heat is dissipated on the plate here, so you can actually remove the spokes. They are called spokes, and if you solder it right here, then much heat of the soldering iron is dissipated, and it will take much longer to solder something in here. So I would recommend just leave it with spokes. You can already, you can of course set the size. If you want them thinner, just set them to about 15, and then you can see they get much thinner. And this is very handy for soldering, so just leave it like it is. And another thing I have to show is when you, for example, make a track, like VCC is fine right here. I will do a track from this to this. So when you then go to copper area, render it new, then you can see that this whole area just now is vanished. It's because there's no connection anymore between this part and this part. You can set that it should be created anyway. Then you have to set keep island to yes. So this is an island, but it's not connected anymore to this, just like an island. And so you have to make another bridge between this side and this side, and this can be done with another ground plate on the whole other side, like this. So now you have a connection between this and this side, but still no connection between the blue side and this part here. So you can do an via, just put it here and make sure that it's on the ground net. And then when you just re-render it, then you have a connection between this side and this side, and you have a connection between this and this through this via. And this is very important when you do the routing. You just have to make sure that every ground is connected to each other, so you won't have to resolder your PCB afterwards because you forget some connections between that. You may see that this happened to me. Yeah, okay. What can I show you now? I will show you the doorbell PCB, and here I have done some special tricks. For example, let me show the 3D view. I have a hole here. This is for the ESP32 chip. It's it's getting quite warm, so I had to make sure that the air can flow and the heat can dissipate. So I put on a cooler on here, and so here there has to be a hole. And how you can do this? It's quite easy. You just have to work with the sides, and this is also applicable to every thing you select, except I guess this is multi-layer, because it's on both sides already. But let me show what you can do with a solid region. For example, I will do a solid region like this, and when you it's not active right now, so here's a bit ugly edge. Let's remove that. So you can just, when it's selected, you can just change the type of layer. So you can, for example, use top silk layer and the color change to yellow. And if you have a look at the, for example, 2D or 3D view, then you can see that there is now a printed white part. This, for example, also applies to text when you add a text here. And now I will just re-render. I don't know how it's done better. So you can see here's a cutout, because this is on the copper layer. And when you want that on the top silk or the bottom silk layer, you just can apply this here like this, and then have a look. And you can see there's the text now like this. You just have to re-render it when you, for example, don't need a copper cut out here. Then just re-render the copper area, and then it's filled again. But if you want to have a real cutout, like this one, then you just have to take this area, for example, you can move it where you want, and just select multi-layer, and then you may guess it, you have a real cutout, just as easy as that. And yeah, you can move it, just re-render, click on 3D, and then you have a hole here. This is also possible as make a hole like this. This is a drill hole, and here you can use it for screw your PCB on your 3D printed case, for example. And I did some cutouts here from the silk layer, no, the copper layer and the silk layer solder mask. Yeah. So when you have a look at the 3D view, you can see there is no silk layer, there's no copper layer, and there's no solder mask. Just for fun, just just did it to try out. Normally you would ground your screw holes. I don't know, I'm not an electrical engineer. I do this just for hobby purpose. And yeah, what can I say? Let's go to the ordering process, I would say. When you want to order your PCB, you have to create an gather file, like generate gather file. Let me show you in this case. The EasyEDA just checks for correct routing, but you can ignore that if you are sure what you're doing. Okay, it's now saved. Generate. I don't want to check connections, and I want to check the DRC. and there's some incomplete connections. No, but I ignore that. So I go again. No, keep going. And now generate Gerber files, and this will generate a zip file, and that file you can just upload to JLC PCB and they will produce your PCB. Just as easy as that. And of course you can also do pick and place if you want to save some solder work for components. Then you go to now where you have it, to LCSC, and then you can, for example, search for a component like the ESP8266, and then there are some parts found, and we want to use, for example, the PCB module. We click on it, and there's a LCSC part number, which you can use in EasyEDA for placing the part as full component. So we use the part number, just found one, and then we place it just like this. And if you then go to 3D view, you can see there's placed, it's quite ugly, but it's just for example, you can place the module like this. And if you then go to fabrication, you can select which parts should be placed directly in the factory, and there you can have a look at LCSC. Most of the parts was shown as in stock, and then you can use them with a special fee. You have to look what the actually fees are for ordering special parts, but there's a list on JLC PCB on where is it? I guess some they have some basic parts, and they are much lower in price as these special parts. I don't know where you can find that, but anyway, just build your board and learn a bit, and then you try to order, and you always can check the prices before ordering, and then you will have your first PCB product in your hands, and it's a very good feeling if you can produce your own electrical parts. And if you have a 3D printer, for example, then you kind of can do your own products in small amounts of just prototypes, I would say. So sorry, I just freestyled my English right here. If this video was not scripted, so I have to stutter a little bit. And anyway, I hope you enjoyed this little tutorial, and stay tuned for more. This winter I have more time for doing creative stuff, and just stay smart and independent, and see you soon.